Now look over here. Should we start? Right or not? Okay. Here we have completed where the EMF of the particle varies linearly with the time. Okay. So let us start from now. Now look over here. Second question. Okay. What it is saying? In the figure shown, what it is saying? In the figure shown, a copper rod moving with a velocity v parallel to a long straight wire carrying current I is shown. Right or not? So you have some carrying current I over here. This is wire which is having some kind of current I. Got it or not? In front of that, you have one copper rod over here. Got it? Which kind of rod? Copper rod. Now you can ask me, sir, why only copper rod? Why not any other rod? So copper has more free electrons. Got it or not? So we have some kind of copper rod and it is moving with some kind of velocity. Got it or not? What it is asking, calculate the induced EMF in the rod, assuming that velocity is given, current is given, the distance A is given and distance B is mentioned over here. Got it or not? Can you do this? Try to do it. Okay, so this is my copper rod over here. Got it or not? Okay, the one end of the copper rod is at distance A from wire. Another end of the copper rod is at distance B from the wire. Got it or not? Yes or no? Now look over here. You have to calculate what? EMF it is asking. Got it or not? Now if this copper rod, look over here. For this current I, what will be the direction of magnetic field? Like this way inside it? Yes or no? For this rod, how the magnetic field? Here, which kind of magnetic field will be present in this region? It will be cross magnetic field, or yes or no? It will be a magnetic field which will be going inside. So you have got your magnetic field. You have the rod which is moving with velocity v. Right or not? What will happen? EMF will be developed. Some force will be acting on it. Lorentz force will act on it, and for that EMF will be developed. Now consider this to be point P, this to be point Q. Got it or not? Or yes or no? Now, can you calculate this by normal formulas? What is the net length of the rod? It is B minus A or not? Tell me yes or no. Directly, can you write EMF is equal to like EMF can be written as magnetic field B into B minus of A into velocity V. Is this will be the answer? Is this will be the answer? Why not? Tell me. Why not this will be the answer? Is this is going to be the answer or not? If it is not, then what should be the net answer? Tell me. So look over here, try to understand. Here, what is different? Here it is not a constant magnetic field. The magnetic field is not constant over here. As you are moving farther away from the current carrying wire, the strength of the magnetic field is decreasing or not? Tell me yes or no. What is decreasing? B for the rod is not constant. First important point is what? The magnetic field itself, the total magnetic field strength which is acting on this rod, it is not constant. Here it is acting in a very high amount. Look over here. At the top end of the rod, it is acting in very high amount. As we move further from the rod, what has happened? Magnetic field strength has decreased or not? Or yes or no? So less forces means at the top end, it will experience much more force. Center, it will experience little bit less force, but the last end will feel too much less force or not? Tell me yes or no. So force is also varying. So EMF will be also varying with respect to every distance or not? Tell me yes or no. So to calculate that, what we will do actually? To calculate that, so this is my magnetic field. Okay. First, as we know, if our magnetic field is varying, force is also varying. So first I will construct one element of length dx. Yes or no? This is the idea or no? What we have to do? Construct an element of length dx, consider it to be located at distance x. Right or not? Yes or no? For that, first calculate how much is the magnetic field over there. It will be what? Mu naught I by 2 pi x or not? Tell me yes or no? Sin theta 1 will be 90, sin theta 2 will be also 90. Right or not? So now B is equal to how much? Mu naught I by 2 pi x. Now try to understand. EMF will be how much? EMF will be what? BLV or not? Tell me yes or no. So is this dx length is also moving with particular velocity v? Yes or no? So therefore this EMF will be what? A small EMF that is going to be how much? B, which is mu naught I by 2 pi x into what is the length of the element? Dx into what is the velocity of the element? V. Right or not? If I integrate it, look over here. If I integrate it, is I will get the potential difference from A to B or not? Tell me yes or no. So now look over here, try to understand. Let us consider this is point P, this is point Q. So if I integrate from P to Q, what I will get? I'll get my what? Net potential difference, yes or no? Now, where is this P located? At distance A. Where is this Q located? At distance? At distance what? B, yes or no? So we will do the integration from A to B towards the right side, yes or no? Is this correct or not? Can you got the answer? What you will be getting? EMF. Okay, change in EMF will be what? It will be equal to mu naught I V divided by 2 pi. 1 by x dx is what? Log x. So log B by A. Yes or no? This will be answer or not? Or yes or no? So net EMF generated over here is how much? Mu naught I V by 2 pi log B by A. Got it or not? Is it okay or not? Good. Write it fast. So you can write over here magnetic field changes. Who is that? Huh? Who is? Amulya, come over here. Magnetic field changes when the distance. Find the acceleration of the moon with respect to Earth from following data. First, solve the examples. Complete all the examples. Completed. All examples. First and 11th. Distance is given. Which distance between Earth and Moon is right or not? And the time taken for Moon to complete one revolution around Earth is how much? 27.3 days. Right or not? So time period is given. Distance is also given. This distance, half of this distance will work as a radius or not? Sorry, this pulley will or work as a radius or not, because moon is revolving around earth, right or not? Okay, time period is given. What is given? Radius is also given. So what you need to know? uh Hey, what happened? Oh shit, suddenly it got deleted or what? You have written now? Okay then. Okay. So you have the radius, you have the time period. So can you calculate what it is asking? Find the acceleration. Acceleration, how will you calculate? Omega square r. Radial acceleration will be present or not? What it? Hey, hey, be silent. Now look over here. Now we have done the questions based upon the motional EMF and all, but we'll try to accumulate all these points with simple basic points which are going to be directly asked in it, right or not? So now look over here. Let's suppose you have what kind of wire? Some kind of semicircular wire. You have which kind of wire? Semicircular wire, and it is semicircular. What kind of loop it is? Conducting loop, not non-conducting. Which kind of loop? Conducting. Why it is necessary to take conducting loop? Can you answer me? Why it is necessary to take conducting loop? Why not some kind of dielectric loop or non-conducting loop? Tell me. Why it is necessary to take conducting loop? Very simple, chacha. Simple. In conducting loop, what is present? Free electrons are present. In non-conducting loop, less free electrons are present. More force will be required, which will not be able to provide. Are you got it or not? So which loop? Conducting loop. Got it or not? So you have conducting loop of radius r with center at O and moving with velocity v. Then the EMF is given by. So let's suppose you have some semicircular arc. Got it or not? Okay, Chandru, not Pari. Okay, so we have some semicircular arc, okay, of radius r. It is moving with velocity v. Right or not? Or yes or no? Now, where will the force act? Tell me. Velocity is acting. So, which force? Which I will apply? FBI. I'll apply FBI or not? FBI I'm going to apply or not? Now look over it. Magnetic field is inside. FBI. Magnetic field is inside. Right or not? Current is where? FBI. FBI. Tell me, where is the direction of current? Upwards. Chacha, upwards. 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 Are upwards? Yes. Yes. Velocity. You can apply BQV directly. Go it or not? FBI or FBV. Go it or not? Velocity is upwards. Where is the force acting? It is acting horizontally. Listen me perfectly. It is acting horizontally. So now look over here. In this particular semicircular arc, for this particular semicircular arc, actually, if you need to consider the conductor length, are you going to consider 2 pi r? So see, look over here. Are you going to consider the length of the conductor pi r? What is the formula of EMF? EMF is equal to EMF is what? BLV? Yes or no? So what is the length of the conductor? Pi r. Is the length of the conductor pi r? No. The direction of force will show you the direction of length of the conductor. Got it or not? Here, force was present along the direction of conductor. That's why we were taking length L. See, look over here. In this derivation, force was present along the length of the conductor. That's why I was taking anywhere. Look over here. The force is present. See this force. Is this force is present along the length of the conductor or not? That's why I have been taking BLV. But here, as I have the semicircular arc, the force is present like this way, horizontally. Now, if you have the horizontal force between the ends of the conductor, how much is the length that is forming? 2r or not? Tell me yes or no. So, therefore, EMF will be given as B into velocity V into 2r. Right or not? So, can you make one note over here? Can you just make one note? Note is what? Take the length of conductor. Take the length of conductor along the direction of force, along the direction of force. Is it clear or not? Clear or not? Or yes or no? Is this okay? Yes or no? Now look over here. Now let us consider the second point. In second case, what you have a conducting rod AB which is moving with velocity v in xy plane. Got it or not? What you have some kind of conducting rod AB now this time. Got it or not? This is my AB rod which is moving with velocity v in xy plane. Now look over here. One thing is important over here in this question, that the velocity is not perfectly perpendicular to the magnetic field. Got it or not? Yes or no? This velocity is making some kind of angle theta with the length of the conductor. Got it? Now, if you have such kind of velocity, I already told now, if you have such kind of velocity, what you will have to do actually for this velocity, you will have to take two velocity direction. Got it? You'll have to take the component of the velocity, one along the length which will be equal to v cos theta, one perpendicular to the length which will be equal to v sin theta. Got it or not? Now, when you will be writing the equation for the EMF at that time, what you are going to say, that the net EMF that is generated is what? Here also magnetic field is going to be B. Yes or no? Magnetic field is what? B. Length of the conductor, let us consider it to be L. Now, here it will not be only V. This time the perpendicular velocity component is what? V sin theta or not? So you will say that EMF generated is nothing but it is equal to BLV sin theta this time, not just BLV. Right or not? Yes or no? If the velocity makes angle with the magnetic field or it makes the angle with the length of the conductor, your net value of EMF is going to change. Okay. Is it clear or not? Okay. Now, if someone asks you, what is the net value of EMF due to that cos theta component? What will be that? Tell me. Is it going out to be 0 or not? Look over here. Due to V cos theta, try to understand. What is the angle between velocity and the force over here? 0 degree or not? 0 degree or not? Yes or no? Between the length of the conductor and V is how much? 0 degree. Now, if you take, it is V cross B, got it or not? It is V cross B or not? Now, V is along the direction, perpendicular to the direction which we have already suggested. If it becomes 0, what will happen? The net value of force will become how much? 0. Got it or not? Yes or no? No current will be produced. Understood? Got it or not? Is it okay? Can I move ahead? Can I move ahead or not? Done? Okay? Can I move ahead? Did you have written? Rakshita, written? Okay, moving to next point. Part number 3rd. Now look over here. This time you have a full circular loop, got it or not? What you have? You have a full circular loop, and this whole circular loop is moving with some kind of velocity v, got it or not? What is the velocity of this circular loop? Velocity v. So now look over here. Magnetic field is inside it. Again, if someone asks you that what is the EMF produced, where is the EMF produced, what will be that answer? So I'll have to consider one length which is perpendicular to the velocity or not. Tell me yes or no. But I'll have to consider one length which is perpendicular to velocity. Got it or not? Now, if you select that length which is perpendicular to velocity, you will see that what is that length over here? It is nothing but it is the diameter of the circle, isn't it? It will be diameter of circle or not? Look over here. Velocity is towards this side. Magnetic field is inside. Where is the force acting? Upwards or not? Or upwards or not? So therefore, you will have to select the length along the direction of force, which is going out to be what? Maximum possible length is what? Diameter. Got it or not? So therefore, in this diameter only, what will be generated? EMF will be generated. P will be upward is always positive, downward is always negative. Got it or not? Because force is acting upward. So therefore, net EMF generated is how much? Twice into V into radius R. Got it or not? Is this okay or not? Okay, 100% okay. Yathiraz, are you listening? Got it or not? Can I move ahead? Move to point number 4. Now, we have done all the symmetrical shapes, got it or not? We have done for first semicircular arc, then length of rod L, then circular loop, got it or not? Now, I have some kind of irregular shape kind of loop. What kind of loop? Irregular shape, got it or not? Array, yes or no? Now, the end points are marked as P and Q. How the end points are getting marked? P and Q. Now, if this irregular shaped loop is moving with some kind of velocity v, how it is moving, guys? It is moving with some kind of velocity v. Okay, it is moving perfectly with some kind of velocity v. Okay, and this v is making some kind of angle theta with the magnetic field. Now, what is the velocity is making? Angle theta with the magnetic field, not the length of the conductor. How it is making? Angle theta with the magnetic field. Got it or not? Magnetic field is inside it. Now, the question is, what will be the amount of EMF generated? Can you tell me? What will be the amount of EMF generated? Can you tell me? Huh? Tell me fast. Okay, so first of all, see that magnetic field is inside. Look over here, hey guys. Magnetic field is inside. Velocity is towards upside. Got it or not? Where is the direction of force? Along the perpendicular direction. If you see the direction of force, how the direction of force will be? It will be in this plane only, but it will be some kind of this way. This will be the direction of force you will be getting. Yes or no? Or yes or no? Right or not? So for this direction of force, I need to consider one what? A perpendicular length, yes or no? Do I need to consider one perpendicular length or not? So let's suppose if you are aware of point P, if you are aware perfectly of point P, and if you are aware of point Q, find the amount of length, find the length of this straight line which is joining point P and Q. Right or not? This will be how much? It will be length L. Right or not? Yes or no? For that case, force is acting towards this way. So first we will have to do what? We'll have to check in that plane, listen me perfectly, in that plane, how much is the direction? See, try to understand. This V is making angle theta with the magnetic field. This, look at the previous question. Here V was making angle with the conductor length, right or not? That's why we included the perpendicular V sin theta. Got it? But here V is itself making what kind of angle? Angle with the magnetic field. So if this is my magnetic field, this is my velocity, right or not? So where is my velocity acting over here? Like this way. This is my velocity. Listen perfectly. This is my velocity, which is making angle theta with the magnetic field over here. Right or not? Yes or no? So for this velocity, what I will have to do? For to get this perpendicular force, do I need to take perpendicular velocity component with the magnetic field or not? Tell me yes or no? Or yes or no? Guys, yes or no? So what will be that value? Can you tell me? So look over here. There will be two components. One perpendicular to this, which will be equal to V cos theta. One perpendicular parallel to it, and that will be what? V sin theta. I'm trying to draw in 3D. Got it or not? Or yes or no? One V cos theta, one V sin theta. Now, if you check for the conductor itself, which velocity is perpendicular to it? V cos theta or not? Tell me yes or no? V cos theta is perfectly perpendicular to the conductor. So, with respect to this, what will be generated? EMF will be generated or not? So, therefore, EMF is going to be how much? V cos theta into perpendicular length, which is between point A and point B. Got it or not? Is it okay or not? Yes or no? So, if you want to draw the battery will be present like this way. They want these driver guys are hero, hero Pante they are doing. Yes or no? We need to put breakers over here before the school. Some days some accident can happen, dangerous. We need to put really in front of the. We need to get. We have at least little bit far away from that side one breaker, from this side one breaker, because in front of the gate the bikes or something like are turning like this way. Yes or no? If that day I was only going, okay, I was I had put at my headphones. Suddenly a car was moving to very fast speed. Okay, and I just went in front of it. He was going to hit me. Then I said, "Oh, tere!" I just moved back. Why or not? So I was having my only kidney within my hands. I was going to have it. Can I move ahead? If you do not score, I will just take out the kidney and sell it in the iPhone store. Got it or not? Okay. Can I move ahead? Yes or no? Okay, moving to point number 5. So you have done the question for previous case. The related portion was for the vertical case, right or not? Here it is horizontal case. So now look over here. Try to understand. Let's suppose you have a horizontal rod PQ. Chachi, what you are doing? Nothing, sir. Nothing. No. You have horizontal length PQ, right or not? This P end is located at R, and length of this PQ is also R, right or not? This is given over here, okay? So one of the ambiguity is given that first of all P end is located at distance R, okay, and even length of this particular PQ wire is given how much? R over here, right or not? This PQ rod is moving with velocity V. This is current carrying wire. Again, look over here. Every end is experiencing different magnetic field or not? How much will be that? So first I'll have to consider one element dx or not. I consider one element of length how much? Dx, which is located at distance x from the wire. Right or not? Yes or no? What will be the magnetic field for that x? V is equal to mu naught I by 2 pi x. Can you do the problem after that or not? Or yes or no? Again, you'll have for EMF, it will be dE this time. And what will be it? Integral from R to, look over here. This time it is R, this is R, and this whole length is how much? R only. So it will be R to 2R or not? Tell me yes or no? Yes or no? Integral, I think it is different variable or same variable. Actually, you consider this is not R, okay? Length of the rod is given L, okay? They have just misprinted in figure, okay? So consider length of the rod to be length L, right or not? So now look over here. From integral will be from where to where? From this end R to R plus L mu naught I by 2 pi x into what? Dx into velocity v, yes or no? This will be the terms or not? Right or not? Can you do this or not? After that, it is your work to do it. Okay? Understood? Is it okay or not? Is it okay or not? It is your work to do it. Okay? Okay. So try to complete all of this. Tomorrow we'll complete self induction, mutual induction. Okay. 1 minute.